All right, guys. Good afternoon, good evening, I should say. Apologies. Welcome back again to the CCNA journey. Um, we are on chapter 8, implementing Ethernet virtual LANs, and this is chapter 8 of volume 1 of the CCNA 200-301 official certification guide library. Okay, I want to make that a point. The official cert guide library. What this means is that, of course, volume 1 of the CCNA 200-301 official cert guide and volume 2 are all one book whenever you purchase the library. Okay. It's a sweet deal. If you're studying for it, I suggest it. I suggest you get the physical and e-copy bundle. Once you do it, it's yours. You can download it. And of course, they also send you a physical copy that I got here. Even though I have my CCNP, I like to go ahead and just still keep up with reading about the CCNA. The thing about it is that with the CCNA, you can never go wrong with going back and looking at the fundamentals. Because if you're not a subject matter expert, you will always need to go ahead and go back and look at some of the stuff. So I suggest all you guys go ahead and get your if you are looking to purchase the official cert guide, get the official cert guide library, so you can have volume 1 and volume 2 together. And then, of course, if you get that bundle from Cisco Press, it'll go ahead and come with the physical version and the digital version. Okay. All right. So with that being said, let's go ahead and pick up where we left off. So we left off, we were talking about 802.1 trunking, right? And we were talking about how, of course, 802.1q and ISL are VLAN trunking protocols, right? So we dove deep about that. We spoke about, as you guys can see, what the frame would look like, right? Whenever we get to that section of the frame and we're looking at, after we look at the destination and source address, we see there's a 802.1q section, right? That, of course, shows us the type, the priority, the flag, and of course the VLAN ID that takes up 12 bits. Okay. All right. So now that we spoke about that, right? We left off on speaking about forwarding data between VLANs, right? So let's say you go ahead and create, right? You create a local area network, right? Either within your enterprise, across the campus, or what have you, right? That has, more than one VLAN, right? Nine more times than one, you want all of these VLANs to be able to send data to other devices and to each other, right? This next section we're going to go ahead and talk about the need for routing between VLANs. Okay. So, right. So layer two switches, right? They forward data based on layer two logic. Okay. Okay. So layer two switches forward data based on layer two logic. Okay. What that means is they forward it based on source and destination MAC address. Okay. All right. So a layer two switch with multiple VLANs would forward traffic, right? Using layer two logic per VLAN. Okay. Let's talk about this. Let me go ahead and get my pencil and let's talk about this using this picture, right? So if we're looking at figure 8-7, right? We have two PCs on the left, right? They sit at VLAN 10. Okay. Right. All right. And we'll call it subnet 10 as well. Okay. We don't have layer three information yet, but this is where we're at. Okay. And two PCs on the right, Wilma and Betty. Okay. Shout out to Flintstones if you guys don't get the reference. Right. Um, we see that they're in a different VLAN. They're in VLAN 20. Okay. But again, we have two different VLANs, right? So the switch is broken up into two different broadcast domains for these PCs involved. Okay, all right. For this using layer two logic, okay, if Dino needed to speak to Wilma, the layer two switch cannot, and I want to make sure I emphasize this point, cannot forward data to Wilma, who is on VLAN 20, using layer two logic. Okay? There is no way to do that using layer 2 logic. Okay? All right? There will need to be a layer 3 instance to be able to route packets, okay? And we can use the term packets now, to route packets between different VLANs. Okay, so then it'll be able to forward traffic or what have you. Forward that packet. That packet gets de-encapsulated to a frame. Um, it gets encapsulated to a frame. I apologize, and then gets sent to the right VLAN. Okay. So, for example, right, if Dino's that's in VLAN 10 sends a Ethernet frame, right? Um, if this switch, right, again, is a layer 2 switch, it receives it, um, and it's trying to forward any traffic to Wilma or Betty that's in VLAN 20, it will not do it, okay? If it is a layer 2 switch. Hopefully you guys can make sense of that, all right? Let's go ahead and clear this up. All right, so now let's talk about routing packets between VLANs using a router, okay? All right, so when we have VLANs included within our design, right? Um, Devices in a layer 2 VLAN, right? They need to be part of the same layer 3 subnet. Okay. All right. Let me say that again. Devices within the same VLAN needs to be in the same layer 3 subnet. Okay. I can just say subnet, but I want you guys to follow, right? Layer 2 VLAN, layer 3 subnet. They need to match. Okay. So, all right. So you guys can see right here, right? Those that are in the VLAN needs to be in the same subnet. No questions yet. No questions yet. We're gonna wait till the end. Okay. All right. So to forward packets between VLANs, the network must use a device that acts as a router. Okay. I want you guys to make sense of that. To forward packets between virtual local area networks, the network must use a device that acts as a router, aka a layer 3 instance. Okay. Now here's options, right? Here's the first logical, fundamental option you can use, right? You can go ahead and install a router, right? Or you can use a switch that performs functions like a router, right? And of course, these switches are called multi-layer switches. They can perform layer 3 functions, right? Or what have you. Some people call them a layer 3 switch. You know, I like to go ahead and of course, most professionals like to reference them as multi-layers because of course it's operating at different layers, right? Layer 2, right? VLAN, layer 3, subnet, okay? And packets, all right? So let's look at figure 8 dash 8, right? And let's take a look, right? So for this example, we have a router, okay? So we have a router, right? This router can route packets between subnets and VLAN 10 and 20. Since we're talking about the router, we're going to say subnets 10 and 20. Okay. So using the same layer 2 logic, okay. So what we have here, right? Let's say Dino and Fred, of course, has IP address in subnet 10, right? And they're both in VLAN 10 off of the same switch, right? Because if we take a look at this design, right? Wilma and Betty are still on the same switch, right? We just have that layer 3 instance, right? So if Dino and Fred sends traffic, it's going to send it to that layer 3 instance, which is that router, right? With that interface connected to that switch, it's going to receive, right? It's going to receive that packet, okay? And it's going to say, hey, this packet is destined for something in subnet 20. You understand? So it's going to say it's for an interface in subnet 20, right? This interface that hangs off the switch coming from the router is in VLAN 20. So now the logic is going to say, hey, from a layer 3 standpoint, I have an IP address here for VLAN 20. This traffic coming in is destined for VLAN 20 and it's coming from VLAN 10 that's hanging off of this interface. And of course, this same switch, right, has me connected off of VLAN 10. Okay. So I know where to forward this traffic. From a layer 2 standpoint, which is right here. Okay. it's going to know, hey, we're going to go from subnet 20 to VLAN 20, right? Because now we're going to encapsulate it, and we're gonna encapsulate it to a layer two, right? And of course into layer one, so get on the wire. When it gets to the switch, it's going to read, right, the frame and say, hey, this is destined for something in VLAN 20. Switches are still operating at layer two. So it can't read layer three or anything like that. Okay. It's gonna say, hey, this is for VLAN 20, right? Here's the destination MAC address, right? Based on the ARP that was done before by the router, of course, before it started forwarding it, right? It did its ARP and say, hey, Wilma, who's maybe 20.55, which of course we'll give it to Wilma's PC, says, hey, got the ARP. Now I know the layer three to layer two mapping. I have the destination address. I know where to send it. The switch is then going to forward that traffic to Wilma in VLAN 20. Okay. This time we went ahead and of course, in this example, it used a outside, right? Outside router, right? This is the best example that you can see. Again, in my explanation, you can use a multi-layer switch that has functions for layer three, right? So let's play this out. Let's say we wanted to do that. We can go ahead and erase this out, okay? And let's say this was layer two and layer three, okay? We would have that instance here, right? Embedded in the switch via software. We would have those instances there, right? So now, from a layer three standpoint, traffic that's coming from VLAN 10 is going to go to the layer three instance of VLAN 10, right? Same process is going to happen, right? Think about what we just spoke about as far as forwarding traffic via layer two to layer three, right? Same thing is going to happen. It's going to get to its router, right? We're going to call that layer three instance that router, right? Embedded in this switch. It's going to say, hey, let me look at my routing table because now I'm looking at layer three. I see an IP address, right? That's in subnet 20. I have a route and, right, I have a connected route and a local route, right, in my routing table for VLAN 20. I know where to forward that. Okay. I'm going to do the ARP. I'm going to do everything that comes with forwarding packets. Okay. And making routing decisions. Once I have that, I'm going to go ahead and forward that traffic. Same thing. This was just the best example, right? To go ahead and look at first, to go ahead and route traffic between two VLANs, right? Using just two physical interfaces, right? Same concept. You can do the same thing via software, right? Using what they call switch virtual interfaces. All right, so let's clear this out. Hopefully that made sense. And let's talk about, let's go ahead and move on. And of course, just to let you guys know, chapter 18, we're going to dive more deep into IP routing within a local area network. And of course, it'll talk about working through, routing through VLANs, right? And of course, other features of just routing in general. Okay, let's go ahead and talk about VLAN and VLAN trunking configuration and verification. That's what we're going to talk about today. Like I shared with you guys, chapter 8 is loaded with things. Okay, it's loaded with so much concepts. This is the main reason why we need to break it down. Tonight, right, is the focus here is forwarding data between VLANs. Okay, so we're going to make sure that we touch on that, right, in which we did. We're also going to go ahead and make sure we touch a little bit on, which of course is going to be a two-part section, 30 minutes max, so I only have 10 more minutes. We're going to go ahead and touch on VLAN and VLAN trunking configuration and verification. Okay. All right. So we'll go ahead and touch on that first, and let's go ahead and jump right in. Right. You guys can see my screen. It's going over the config checklist, but let's go ahead and just break it down. Right. By default, you guys get a switch. Maybe you get a Cisco 9K. Out of the box, you can plug that switch in. It requires no configuration to forward frames, right? Because again, when we talk about the three major functions of a switch, right? Those three major functions, right? Forward frames based on the destination MAC address, okay? Filtered frames, right? and of course, loop prevention. Okay, so um, that's what all that's needed, right, from a switch coming out of the box, right? And it'll go ahead and work, right? You never need to go ahead and from at the base level. If you want the switch just to do those jobs, you never need to configure anything. You just plug it in. Of course, you can do basic management, add an IP, et cetera, et cetera. You can do all that, but no real big configuration, right? Even if you're interconnected with different switches, you don't need to go ahead and do that. Okay. You don't need to configure anything, right? Now, once you do, if you have the need, okay, to configure, right, more than one VLAN, right, which of course most enterprise networks do, you got to add some configuration, okay? So this is where, and of course, if it's going to be interconnected with different switches, right, different devices, it's going to require some configuration, right? And so what happens is in this section, right, we're going to talk about VLAN configuration, right, in two major sections. That's why I said this is going to be short. And we got to break this up, right? The first section, right, of VLAN and VLAN trunking configuration and verification. This section, right, we're going to go ahead and look at how to configure static access interfaces, right? Switch interface is configured to be in one VLAN only, right? Therefore, it won't use VLAN trunking. The second part of this section that we're going to go over is going over how to configure interfaces that do use VLAN trunking. Okay? All right. So let's dive right in. Let's go ahead and talk about it, right? So how do we create a VLAN, right? We create a VLAN by creating that VLAN, giving it a name, assigning interfaces to the VLAN, right? We can go on and go on and on, but let's go ahead and focus just on the basic details, right? Again, on the exam, you're going to be tested on how to do this. They're going to ask you in question format, right? Okay. So we have the Cisco 9K, okay? Um, and we want to go ahead and create multiple VLANs, right? If we want the Cisco 9K, right, whatever switch we're using to forward frames in a particular VLAN, the switch must be configured to believe that the VLAN exists, okay? In addition, the switch must have non-trunking interfaces. This is an important one, what I'm about to say. In addition to this, the switch must have non-trunking interfaces, access ports, okay? In the book, they'll say access interfaces or static access interfaces, right? But we're going to keep it simple, access ports assigned to the VLAN and or trunk, right, that support the VLAN, okay? Let's go over the configuration steps to go ahead and want to configure a VLAN and to add a interface to that VLAN. Okay. So step one, right? Step one dash A, right? We'll go ahead and this is the configure a VLAN. We go to global configuration mode, right? We use the VLAN, right? VLAN, and then of course the keyword VLAN dash ID. So of course we'll give it an ID, a number, right? Command in global configuration mode, right? To go ahead and create the VLAN, right? And to move the user into VLAN configuration mode, right? We're going to go ahead and move into VLAN configuration mode once we put the VLAN and of course the number, okay? All right. Optional, we can use the name, of course, in the name command in VLAN configuration mode to list a name for the VLAN. If not configured, the VLAN name is going to be VLAN XXXXX, where XXXXX is the 4-digit decimal VLAN ID. So for example, if it's VLAN 4, right? If you don't put a name on it, it's gonna the name for it whenever you do a show VLAN, you're doing some verification, it's going to say the name for this is under the name column is going to say VLAN 0004. Okay. All right. Highly encourage. I highly encourage, right, to go ahead and put a name whenever you create a VLAN. Okay. You can name it by its purpose, what it does, etc. Okay. Let's move on to step two, right? For each access interface, follow these steps. Use the interface type number, okay? So interface, maybe gigabit, gigabit Ethernet, right? 0/0/1, right? For example, right? Command in global configuration mode, right? To move into interface configuration mode for each desired interface. Okay. And in your head, you have to think about for my design, I want to put this interface in this VLAN. But first, I need to go into interface configuration mode. So now that I did it, the next step, right, to go ahead and add this interface to the VLAN that I just created, I need to use the command switch port access VLAN and the VLAN of the desired in the VLAN ID of the desired VLAN that I would like to put this interface in. Okay, we'll use the VLAN that we just created, VLAN 4, right? We do that and we'll specify that VLAN number. Okay, once we do that, now this interface is associated with the specific VLAN that we just configured. Okay. Step 2 .c, right? We can use switch port mode access command and interface configuration mode to make this port operate in access mode. That is not to be a trunk. Okay. Um, I recommend this wholeheartedly. Before you do anything, right? Before you do anything, you always want to check a configuration, right? You do a show startup config, show running config, right? You take a look at your configuration and of course the port and you can drill down, you can do a show run interface, gigabit 0/0/1, right? You look at the configuration and sometimes, right, if there is on certain code, right? I know on future builds, it may or may not have, right, that command switch port mode access because by default, right, it's known, right, for those that read the literature, the book, the theory, of course, it's implied that every port out of the box is a access port and it's in access mode. Okay. Verify that, put in the command, okay, like you guys saw in earlier chapters, go into global configuration mode, go into interface configuration mode of the desired interface, put this command in before you start configuring anything, right? Do another verification, right? Then once you do another verification, you verified, hey, this is a port that is in operating in access mode. We are good to go, right? To follow through with our design to put this in a specific VLAN, right? And it to be an access port. Okay. All right. So, and of course, you guys heard me. As far as I said, out of the box, ports are in a. Of course, they have a specific configuration where most of them are access ports, right? Just want to make note, right? Out of the box, all ports out of a switch are in the default VLAN, right? Default VLAN, in Cisco's case, is VLAN ID 1, right? So each port out of the box is going to be in VLAN 1. Okay. So whenever you do a show run config, right? I'm a show run, apologize. You'll go ahead and see that it won't have switch port access VLAN and VLAN ID, of course, being 1, because it's implied that all ports are in VLAN 1. Okay. But it's always good to, of course, to verify, right? To make sure, hey, is this in VLAN 1? Let's make sure. Let's do a show VLAN. Excellent. We did a show VLAN and we can see these ports are in VLAN 1. We can also, triple check, right? When of course when you become older in the game of routing and switch, you start doing multiple verifications, right? So you'll even see and show VLAN that it's in the right that the port's in the right VLAN, but you'll go ahead and just do extra verification. You can do as much verification as possible. More the better. That makes you at peace. Okay. Um, so I just wanted to make sure that that made sense. Okay. So we spoke about how to configure a VLAN, right? Let's go ahead and take a look at um, this example, right? So we see this switch, right? One switch has 3 VLANs. Okay. Um, so figure 8, 9, right? We got one switch, 3 VLANs, right? And we have them off of different ports, right? Um, all the way to fast Ethernet 0/1, all the way to fast Ethernet 0/16. Okay. Two of them are in each VLAN of the three. Okay. So we can go ahead and see, right? By default, like I told you, if we do a show VLAN brief, right? What you guys just saw is the design of what we want our ports to be, right? We want them to be in specific VLANs, right? VLAN 1, VLAN 2, and VLAN 3. We don't have VLANs 2 and VLANs 3 configured yet. We have VLAN 1. So, for example, right, for figure 8-9, we have interfaces fast Ethernet 0/11 and 0/12 configured already. That's here, right? That's right here. We have that set, but we need to create a different VLAN so that we can go ahead and add 13 and 14 to VLAN 2, right? And 15 and 16 to VLAN 3. Okay, let's keep going. All right. So now, first, using the configuration checklist, we need to first go into global configuration mode if we want to go ahead and configure a VLAN. So we go ahead and do that, right? We go to global configuration mode. We put VLAN, and of course, the VLAN ID that we desire, right? And for this, right, for our design, for this example, we'll say VLAN 2. We'll create that first. And the name of it, we'll go ahead and put a name. It says Fred's VLAN. So we put that name there, okay? And then we exit out of VLAN configuration mode. Okay. Now, if we go back to our design, we see that we wanted interfaces fast Ethernet 0/13 and 14 in VLAN 2. Okay. So, like you guys learned in earlier chapters, if we know and we want to configure multiple interfaces at the same time that will have the same configuration, we can use the interface range command, say the type of interface, the number, and then boom, right? We can go ahead and do that. So we go ahead and do fast Ethernet 0/13 through dash, of course, the port 14. And then we say, hey, switch port access VLAN 2. Okay. And then of course switch port mode access. Okay. Um, guys, I'm gonna give you guys some advice. I disagree with the book. I say do switch port mode access first, okay, just to be sure, right? That the even though we're gonna do our verification commands, doing the show run, and of course looking at the interfaces, always do switch port mode access first. Make sure that port is in access mode first, then assign it to a VLAN. We don't want to get a syslog message that, hey, you can't do this because this is a trunk port, right? And it's all because you didn't do a verification. Okay. Even if you did, you'll trust but verify. Okay. So we went ahead and configure that. Now let's verify using a show command that these interfaces are in the desired VLAN that we want. In VLAN 2, we saw in our diagram that fast Ethernet 0/13 and 14 were in VLAN 2. So this is as expected. Okay. All right, let's keep going. All right. To further our go ahead and verification, right, and configurations, right, we go ahead and take a look and do a show run config, right? We can go ahead and see, oh, VLAN 2 is here, the name of it, right? And of course, we scroll a little bit more down in our configuration, right? Of course, as you guys can see, some lines are omitted, right? So it's not going to be immediately down if you guys look in a switch, right? We can see, right? 13 and 14, same configuration, switch port access VLAN 2, and they are in access mode. And of course, we can also do an extra more verification and do a show VLAN ID 2, and we can actually see the ports being in the correct VLAN. Okay. You want to verify as much times as you can. Okay. All right. This next configuration, right, example, right, for configuring a VLAN, there's a shorter way to go ahead and do it, right? So let's say we need to go ahead and configure because we still haven't put interfaces 14 and 13, I mean 15 and 16. in VLAN 3. We don't even have VLAN 3 configured. A shorter way to do all this and to configure a VLAN, right? We can go ahead and go to global configuration mode. We have to do that anyway. We can go into our desired interfaces we want to make change to, right? But we can go ahead and say, hey, let's add these ports, right? Assign them to VLAN 3. We don't have VLAN 3 configured yet. That's no problem. Once we put in this command, the switch is gonna pop a syslog message within the terminal and say, access VLAN does not exist, creating VLAN 3 now. So it's doing two things. It's putting these interfaces into VLAN 3, and it's going to go ahead and create VLAN 3. Not in that order. The order is the reverse, but it's creating VLAN 3, and it's also following through with your command. We're putting them in VLAN 3. Okay? All right. And as you guys can see with our verification, with a show VLAN brief, that our interfaces are in VLAN 3. Okay. We can come back later and, of course, assign a name to the VLAN. But if you do this shorter method, it will not automatically put a name. Or I would say there's no way, if you configure this VLAN using this method, there's no way to go ahead and add the name in that same command. Right? To my knowledge, not yet. Okay. All right. With that being said, okay, we're going to stop here. Next section, we're going to talk about VTP, but we'll do that on a Sunday because that's going to be its own section. Even though VTP is ignored by the 200-301, I still want to talk about it. I still want you guys to know about it. It's in the book. There's a big section, and you guys can understand it just in case you guys need to troubleshoot it one day. And I actually earned my stripes, of course, when I was working at Cisco on Enterprise Tech, right? Enterprise Route and Switch Technical Assistance Center, right? And I actually there was actually a customer that was using VTP, and I was able to troubleshoot it in less than 15 minutes without even looking at any configuration, any theory, anything, right? This is just me labbing and testing it out. So we'll go over that on Sunday. Okay. With that being said, with what we went over today, and I want to make sure I'm clear. Is there any questions?
Hi, Dave. Thanks for delivering the session here today.
Mm-hmm.
I do have a question, but I mean, stop me if you think it is not part of it, but I feel like I have a question regarding the figure 828. The diagram you were showing on the screen here with the switch cut it into half.
Let me know which one. 8.8, this one?
Actually, just go back one more. Yeah, exactly this one. No,
okay.
This one.
Sure.
So just want to understand here, like Dino sending a frame out of his computer will be an untagged frame, which basically is like a standard frame, right? Switch port that connects to the Dino's computer is configured for the VLAN 10. Does the switch tags the frame when it arrives at the switch? And then what happens when it actually forwards that same frame to Fred? Does it just send it right away with the same tag? Like, does the tag get removed right when it leaves the switch?
So good question. I love that question. Because I think I told you guys before, tagged and untagged does not get talked about a lot within the CCNA. That is something that you, of course, will need to learn on your own, right? But I told you guys I was going to do a section for you
Okay.
just for tagged and untagged and to show you guys what that looks like. As far as your question, I'll go ahead and answer it.
Thank you.
Remember I shared with you in our last session, there's no way for a PC to, and again, by default, I'm not talking about hacking or any cybersecurity weird stuff. There's no way for a PC to give itself a VLAN ID.
Mm-hmm.
You understand?
I do.
That happens when frames are ingressing into a port on the switch, and then that port is in a specific VLAN. Okay? Now follow me. That's dedicated for traffic within that VLAN, aka broadcast domain. Okay?
Okay.
Tags are only added whenever traffic is sent between interconnected switches, and that's done by design. Okay? So,
Hmm.
for our example here, this is just layer 2, right?
Yes.
It's not going to go ahead and tag packets, right? Because it can't route traffic. There's no need for it to do that. It's going to
Okay.
say these ports are in the same broadcast domain, right? I have no interconnections to different switches. So there's no need for me to tag this traffic. I just know this is dedicated for this VLAN. This part
Okay.
of the switch is not going to see any tags, or this switch in general is not going to put tags because it's not using a function that requires tags. That function that only requires tags is trunking.
If
Okay.
it's not going to require to put any tags on it, why would we even have VLANs on it?
We have VLAN to separate the broadcast domain. Remember, we were speaking about earlier, right? Is that if we have different departments, right, different things, right, we want to go ahead and limit the amount, the size of the broadcast domain, right, to
Okay.
simplify troubleshooting efforts, right, right, and to specify, of course, purposes for our networks. For example, we may have a printer VLAN, we may have a IoT VLAN, we may have a door security VLAN, we may have a user VLAN, we may have maybe an enterprise uh, um, engineering department. We want to make sure that we don't put everything one in VLAN one, especially if we're talking about an enterprise LAN. We also want to go ahead and limit the size of the broadcast domain as much as we can, okay? To eliminate the possibilities of broadcast storms, to eliminate the possibilities of the switch working, the switch working at a high rate, right? If there's something in a security sense, like a broadcast storm or a bad actor on the network that can take down the entire network. We know that, hey, if there's an issue on the printer VLAN, for this example, we can isolate issues just to that VLAN.
Okay.
Does that make sense?
It does.
Okay. All right. But again, I want you to understand and read back up, right? On your own time, and trust me, it took me a while to understand it and learn it too, right? I want you to read back at the first section of the chapter that goes over 802.1q, right? Trunking and how it works. And I'll drop a YouTube video as well. And
Okay.
also go over VLAN tagging concepts. Okay? Because again, these tagging is going to be used whenever a VLAN trunk is created to interconnect with another switch. Does that make sense? Because we need to specify on that trunk, hey, this traffic came in to this port, right? And I'm sending it over this trunk because I configured this trunk to be able to pass traffic on all VLANs. So I need to identify, so we need to be able to communicate and say, hey, this traffic is for VLAN 10. This traffic is for VLAN 20 for the traffic that's passing through. If I don't have an interconnection, let me go ahead and clear this out. If I don't have an interconnection, right? This is it, right? If I don't have an interconnection, there's no reason for me, if there's no connection between switches, is there a need to go ahead and tag frames
If for layer two, it
for layer
won't
two?
require.
Only for layer two is if I
Yeah.
do not have a trunk, is there a purpose for tagging frames that are passing through? Because
Uh,
the concept of VLAN tagging comes from trunking. Talk to me.
I want, but I'm trying to open. I think I'm opening the can of worms.
Mhm.
Uh, I'll just say it here. I think my understanding working with HP now, uh, making me more clear how tagging works.
Mhm.
So what it really means to me, let's just say, for example, right now, we don't have a trunk in between those two switches, but if we have a layer three switch sitting there, let's say just switch one is a layer three, and
Mhm.
it has two different VLANs on four different ports.
Mhm.
Uh, VLAN 10, those two computers will be able to talk to each other, but as soon as it needs to try to talk to the VLAN 20, they'll be looking to speak through the layer three switch. So then they're going to need the tagging for sure.
I want to make sure I understand what you're saying. You're saying
So if
if we don't have a
not
trunk,
the router on the not the router on the stick,
okay, okay,
um, but can we have like a inter routing just on the single switch though? We can, right? Like if you have a layer three
absolutely,
switch, yeah, that's where I was going.
okay.
Um, if if we have a layer three switch just by itself, no
Mhm.
router on the stick, and it
Mhm.
has a two VLANs, uh, communication between those two VLANs will actually require tagging. So it will require like a 802.1q added into the standard frame to
You
pass
ready?
the traffic.
You ready for me to wow you?
Yeah, please. I That's why I'm
So
here.
yeah, so this is why I brought up this picture. So
Yeah.
router on the stick or um multi-layer switch doing the same thing, it's the exact same thing. I think what's happening in your brain, you can stop me if I'm wrong. I think you're conceptualizing layer two and layer three doing the same thing. Okay. This is why I wanted to show this diagram. You said that tagging needs to happen if VLAN 10, right? If we're using a layer three instance, no matter if it's
Okay.
ROAS, or we could take this out. Let's say we take this
Okay.
out and we just have this layer three interface that's embedded on here. That layer three
Okay.
instance for VLAN 10 and VLAN 20. Okay, we're going to walk through it. It's going to be a SVI for VLAN 10.
Yes.
It's going to be hold on. It's going to be a SVI for
No.
VLAN
No.
20. Okay,
Yeah.
what the switch is going to do whenever you create, right, is whenever you create a layer three instance, as long as you have a layer two instance as well, it's going to be created. And it's going to go ahead and create routes within the routing table. That route within the routing table is going to have a local route and a connected route. You understand what I'm saying? So
Yes.
it's going to have that, okay? And it's going to be the exit point, right? That's why we call it instance. It's going to be that exit points for all things within, from a layer two standpoint, of that same number. So if I have SVI, right, interface VLAN 10, all things from a layer two standpoint for VLAN 10 is going to go to my layer three instance of VLAN 10. Here's what I mean. If Dino and Fred are in subnet 10, let's say 10.10.10.50 and .51, we'll give it those IP addresses, /24. My gateway, my layer three instance, on this same switch, my multi-layer switch, 10.10.10.1. You understand? If
Yes.
Dino and Fred wants to send traffic, okay, they want to send traffic to VLAN 20, what's going to happen? It's going to go through the process. Okay, I don't know what that is. It's going to go through the process of first doing an arc, right? Because we can't send traffic based off of just layer three alone within layer two, right? We need to learn the MAC address. We need to know how to forward the frame. Can we agree?
Yes.
Okay. So Dino and Fred is going to say, hey, I'm a host. Let me go ahead and do an ARP request. Hey, here's my broadcast message. My gateway on my PC is configured for 10.10.10.1. I don't have in my personal MAC address table where 10.10 on my personal ARP table where 10.10.10.1 maps to. So I can't encapsulate packets yet. Okay.
Mhm.
My destination is 10.10.20.50 and 51, Woman Betty, right? But I need to know where to send it to. I need to send it to, and again, from a layer 3 standpoint, I need to send this to my gateway. Okay. So once I realize that, it's going to say, hey, ARP, who's my gateway? It's going to find out my gateway. My gateway is that SVI. Excellent. I have a MAC address now, right? Because now I have an ARP reply to my ARP request. Excellent. Now I'm going to forward that traffic from my PC through the switch port, and the switch is going to go ahead and get it via software to that SVI, right? That layer 3 instance. I'm still not tagging. I'm still not tagging because Dino and Fred are ports within a broadcast domain. That broadcast domain has a layer 3 instance. Still no need for tagging. I'm doing inter VLAN routing here. Okay.
Mhm.
So, with that being said, what the switch is going to do from a layer 3 standpoint, it's going to de-encapsulate the frame, right? When it gets to that layer 3 instance, it's going to de-encapsulate the frame and turn it into a packet and say, hey, this is destined for 10.10.20.50. Let me look at my routing table. I have a local and connected route for this because I have an SVI for VLAN 20 as well, right? AKA subnet 20. So I need to go ahead and I need to say, excellent. My path using my forwarding information base to forward this packet is to forward it to, using inter VLAN routing, forward it to interface VLAN 20. Okay. So now it's going to go down, right? It's going to go past the layer 3 boundary of VLAN 10 and it's going to go to VLAN 20 as far as the destination. The switch is going to say, excellent. The destination is for 10.10.20.50. We'll say Wilma. I put now the packet is on, right? Is at the layer 3 instance of VLAN 20, right? Then the gateway, right, for Woman Betty is going to say, hey, I have a packet for 10.10.20.50. I'm going to do an ARP. Hey, who's 10.10.20.50? Woman's going to say, hey, I'm 10.10.20.50. Excellent. Tell me what your MAC address is. I get the ARP reply. Now, the switch now says, hey, the packet goes from layer 3 to go ahead and layer 2. Now I'm going to go ahead and forward that frame only to this frame that's dedicated for VLAN 20. I'm still not tagging anything because tagging comes from the concept of trunking. I don't have a trunk here. Inter VLAN, inter VLAN routing and VLAN trunking are two different things. You understand what I'm saying?
Yes. It's the layer 2 switching um, logic to the layer 3 routing logic. I
Mm-hmm.
think I forgot that one completely
It's okay.
when I was
It's okay.
trying to understand.
Yeah.
I'm gonna bring you like, here's the thing. I'm taking a little too much of your time, but
No, no, it's
thanks
okay.
for
It's okay.
explaining that.
It's okay.
Since you like ever since you said SVI, everything clicked in my mind. Uh,
It's okay. It's okay.
yes,
It's okay, brother.
uh, but I will draw some like I'm gonna do some paperwork, draw
Okay,
some line, like a diagrams, and show you something, and you say yes or no at the end, and let me know. And if I'm wrong, just let me know where I'm wrong on those one, because
for sure.
this has been bothering me from last 8 months since I started
Uh,
working with the HPA
ah,
equipment.
okay. So
Uh,
it's
I,
something at work you're trying to understand.
it's not that, but when
Okay.
I started this work, I knew how to get the VLAN 10, like I knew how to get the VLAN working
Yeah.
and the trunking working for Cisco, because that's what I learned, and everything was like it rang bell to me for, and even I right now I can configure a switch right now if you give it to me for
Yeah.
trunking or for VLANs. But that's just remembering the commands. That doesn't
Got you.
that doesn't make sense to me, that if I was able to understand what really happens in the switch.
Ah, I
And
got you.
when I
Okay.
got when I got to the work, the guys I work with, they not like only the command guys. They just know how switches work. They know how forwarding works. So
Ah,
yeah,
okay.
they
Okay.
didn't let me breathe there. So I had a very hard time. And even now, Cisco, like I'll say it right now, Cisco makes things a little bit more different than
Complex.
how it should be.
Yeah.
They make it complex. It should
Yes,
not be as
absolutely.
complex. Uh, and that's why I kept saying tagging and tagging and native VLAN. And
Yeah.
that's what the anyways, I'm gonna try to like get some. I'm trying this one for myself too, because I have to train a couple of new guys
Okay.
for my own job that I do. So
Okay.
they really needs to make sure they understand the way that I understood from the other guy.
Got you.
So um,
Got you.
that's what my plan is for the next couple of weeks, and
Okay.
I'll try to present it to you. If you could please spare some time and look at that and tell me if if I could actually explain someone in a way or not.
Okay. Yeah,
But
no, I'll be
to,
down for that. The only thing I'll
okay,
request for you to do, just once you have everything together, just go ahead and just let me know and say, hey, Dave, I have everything together that I want to present to you. Can we get, an hour or two of your time so I can go ahead and go over this. And then me and you we'll sync up on time and then we'll go from there.
okay, perfect. I appreciate that, Dave, a lot.
No problem.
But sorry to give you a little. Thanks for explaining, though.
Mhm.
But yeah.
No, it's no you